Hello, everybody. My name is Vahid Garousi, and I have with me here Alper, Buğra, Keles, my great collaborator from Turkey, from Sahabet Testinium Corporation in Istanbul, Turkey. Today, we would like to present the results of our collaboration in the last about 1 year and a half. Next level of test automation with model-based testing. We will share with you our experiences and also the best practices that we have learned. So this is a collaboration between myself. I'm a senior consultant for Bahar Software Engineering Consulting Corporation, and also I also work as an associate professor in Queen's University Belfast. Together with Alper, we have two other great collaborators in the company, Yunus Balaman and Zeynep Özdemir Güler. Okay, so perhaps, and this is going to be kind of a joint talk presentation by me and Alper, so perhaps Mr. Alper also can say a few words to introduce himself. Please, Alper.
Thanks. Hi, everyone. I'm Alper from Testinium. I'm working as a project leader at Testinium. Today, it's really great. This presentation will be really great for us. I'm really happy to be here with presenting our work with Garousi. So, thank you.
Great, thanks a lot. So, you are seeing a number of logos on the right-hand side. This is Our MBT, Testinium, Bahar Software Engineering, Queen's University. The funding for this is a joint research and development project. Funding has been provided by TÜBİTAK, which is the Turkish Scientific and Research Council. And also, towards the end of the talk, we will present the wider context of this project, which is also receives the funding from European Union and also Testomat project. We will have some final slide about this at the end. So, the outline of our talk is as follows, and as I said, this will be a joint talk. Alper will kindly mention an overview of the industry context, so we have the kind of logos who will present what. Then I will talk about the need for model-based testing, really why we did this project. And then together with Alper, we will present our approach and how we applied model-based testing. Then Alper will present the benefits, right? So because whatever you do, we do on a given project, we really need to essentially assess its benefits to see if it really worked and what kind of benefits it provides. And then I will talk about current and next steps of our project. Last but not least, I will mention essentially the takeaway messages for the audience, right? What kind of messages, that the audience can take away from this presentation. So, Mr. Alper, for you.
Thank you. So, a review of our industry context. Testinium is a provider of testing services and solutions in Turkey and across Europe, which also founded in 2010 and providing automated testing solutions to more than 60 clients in several countries so far. In addition to the services offered to clients, we have two main applications developed in-house as a test automation solutions. So Testinium is a test automation management tool that provides you to end-to-end management for your testing process. And Lodium is a web-based load test management system performance testing tool. Yes, actually, okay, we can.
Sure. And then I think, yes, the company has a number of clients, as we can see there, right, such as ING Bank, eBay, and of course, more information can be found on Testinium website. Great. So then now we will, Alper will kindly talk about, this, one of the flagship tools in the company, which is in Testinium.
Yeah, as I mentioned before, we have a great test automation management tool named Testinium. For this work purpose, we pick our test automation management tool named Testinium as a software under test. Testinium is a web application which provides various test management features with three entities, which are project, test suite, and test scenario. Also, we use behavior-driven development approach with Gauge framework for this work as well. So now you can see there are some screenshots from our tool, Testinium. Okay.
Exactly. So yes, I mean, Testinium essentially is a web interface, provides lots of test management features, including being serving as a web interface to the Selenium popular framework. Yes. So I also would like now to talk a bit about what kind of test automation and approaches has been used in the company since its inception in 2010. Many test automation frameworks are in use. Of course, the goal of our particular project was actually to take this to the next level and to improve them. They were already great. We just wanted to make them greater. One of them was Gauge, which, as Alper mentioned, is a behavioral-driven development tool and takes it to the next level. Perhaps the audience know the given, when, then type of approach in BDD, which is okay, but has certain limitations. Gauge, for those of you, again, the URL is mentioned, gauge.org. People in our audience can have a look at its website and see that it's really takes testing to a full natural language. You can write any sentence and then you can write your test in that way. And of course, the company is using its own flagship tool, Testinium and Selenium and JUnit and a few other things. For test case design, in the company, we have been using established black box testing approaches such as category partition, boundary value testing, and other things. But essentially, the point is that, as also reported by other testers, making sure that all test engineers apply all the black box approaches in a systematic manner is not trivial. And well, I can say this because I've been collaborating with more than 30 test companies in the last 20 years, and I've seen that although there are many techniques, but we need a better mechanism really to bring in a systematic test cases, and so that we don't miss important test cases. And we need to essentially make everything efficient, right? Because we need to reduce number of test suites, but have them as strong as possible in fault detection. If I may, I will talk a bit about the need for model-based testing. Essentially, just going back, essentially the last bullet point, to bring in more practices to make test case design more efficient, we brought in model-based testing. So that was the main motivation why we used it. And I'm sure the test engineers listening to this video know that while test automation essentially is, by the way, I'm gonna make my video a bit smaller so that the slide number is visible. Yeah, something like that. Test automation, essentially, test automation tools are effective for automated execution of tests, but tools are not enough by themselves, because we need the know-how and also the strong expertise in test engineers to be able to use tools properly, right? If you give tools to anybody, you can have a situation that they are not used properly. And we are raising a question here, right? So how many of you think this statement is true? So that's a small exercise for people, for the folks who are listening to this. Essentially, in the worst case, if test cases are not designed properly, a test tool will only run bad quality tests. So you will have tests that are not doing a very useful thing. Also, we need systematic test case design, and then most of the efforts in industry are in that direction. And even we have put as example scenarios. So imagine you have two testers, A and B, tester A, and you have, so we are showing two kind of pictures there. Suppose tester A designs 10 test cases, and they would detect 10 bugs if you run them. Tester B designs 100 test cases, and if you run them, it detects 2 bugs. And then the question is, which one is a more effective test designer? I'm sure everybody will say number A, because with, as they say in English, right? Less is more. So you want to have less test cases, but the more default detection. And model-based testing is an effective approach for this need. So now we'll talk about our solution, right? How we applied model-based testing. And of course, I will talk for a little bit, and then Alper will take over so that we ensure that we both have some good chance to talk. Okay, so model-based testing. I will just mention the basic idea of this. It has been around since 1970s, so it's not a new concept. There's even a paper by IBM written in the year 1975 that was the first model-based testing in practice. If you, by searching in Google, right, you can say model-based testing IBM, you may find that paper. It was done on an industrial project in IBM. So it's really, we design test cases. By the way, in terms of time, we are in 10 minutes, so I'm taking care of time through my iPhone in 10 minutes. So we are good. Designing test cases. So you can use model-based testing for system testing, performance testing, and other things. We used it for user interface system testing. You can use it even for integration and unit testing as well. So in this approach, we need to define and design the GUI, the flow diagrams. We need to say how the user interface changes when you do certain events, when you click on different parts of the page of the system under test. So essentially, I'm showing an example here. So we have a set of nodes and edges, or nodes or vertices. For example, for Testinium, we have the main screen here. And by the way, yeah, I can go to Testinium. So if you go to Testinium Live, essentially you have this situation. This is the login page. After you log in, you essentially go to the dashboard page. So let me just test it again. So it comes here. So really, the situation is that essentially you have the start going to the login page. Then we need to verify that we're on the login page. And of course, these things are designed by test engineers. There are ways to automatically crawl these things and reverse engineer them. But in this project, we haven't used them because those tools are not perfect. They will just give you sometimes extra nodes. But I just want to mention that such technologies also exist. They're called like crawlers or reverse engineers. In login page, if you do valid login, valid username and password, it should go to dashboard page as I just demoed, and then we need to verify that that happens actually. So, and then if you put invalid username, password, invalid login, invalid email, it has to give an error message for that, and it should come back. So that is the basic idea of model-based testing. In a way, it actually automates both test case design and also test execution, because once you have done it, as you can see, this is one test case, this is a second test case, this is a third test case. It will just go through all the paths, and you can have many, many, many paths as the graph, as this model grows in size. So essentially, it derives all the possible paths, and which would be very effort intensive if you do it manually. You can have hundreds or thousands of test cases this way, which is a very good idea. And I just want to mention that model-based testing is very popular in industry. So if you do a Google test, a Google search, it brings up about 500,000 hits. So there are lots of model-based testing discussions, white papers, scientific papers, YouTube videos, PowerPoints. So you can read their books. There are several books. I know at least about 5 or 6 books on model-based testing. So there's a huge amount of knowledge. But our goal from this presentation is really to encourage more companies to use model-based testing because we have found it useful. For Testinium, which is our system under test in this project, for example, this is the entire login model. This was the part that I just showed, right? So that go to login and then verify it. But we have the forgot login page, forgot invalid password, all the other things, or log in using Google or LinkedIn or GitHub. So we have now entire model here. By the way, we make all these models and code available in GitHub, and we will provide the URL in a few slides. Okay, I think I have one or more or two more slides before I hand over to Alper. Yes, we have Mr. Alper coming in a few slides. Okay, so choosing the right MBT tool is very important. There are hundreds, there are literally hundreds. If you search for model-based testing tools, you will see hundreds of tools online. We had a certain context. We were testing model-based web applications. We had to choose the right tool based on type of system under tests, our testing needs, other factors. It's a non-trivial question. Actually, this by itself is an online subject of conversation among many people. So choosing the right test tool. If you just search on Google, you will see many people are talking about this. Criteria for selecting the right tool, and we in our research domain, we have been looking at these things. After quite a few weeks of systematic comparison, we chose the GraphWalker. We have this URL. It's a free and open source tool and has been used by many people as a wide user base. Now we have actually a video to show you. So, which is kind of, which also give more information and examples of how this model-based testing works. I'm gonna now load it up essentially. So if you just take this URL, in bit.ly, MBT videos of Testinium, just come here, we paste it here. It brings up a YouTube playlist and has 4 videos. 3 of them are in English, 1 is in Turkish because we are a very international group, so we have in other languages as well. The last one's about model-based coverage, but so I think one of the good videos to watch is this last one, this third one. I'm gonna load it. So,
and all the other directions.
So I'm not going it's me talking again on them, I know, talking everywhere. So,
here step by step.
So if you go there, as you can see, it's actually you have the model. We have designed the model here, and this is system under test. As the model runs, it actually tests different combinations of different scenarios and pages in the system under test. So this is Selenium. Sorry, Testinium. So if you just play it, you're just gonna continue, you see, and it becomes bold. It means that it's currently running that edge and that node. And this is actually the dashboard page. You can see here this in the small font. Even we could make it the full screen, see it like that. So yeah, it's kind of continues like that, and we provide the URL so you can go ahead and watch it as well. Besides this this video presentation that we are providing right now. So it now goes to scenario edit page. As you can see, it goes to all scenarios. So there are about 18 test models, and so it's a very huge. And Alper will provide more details about the size of the model. So I'm just gonna minimize the screen and go back to our presentation. As I said, the entire test suite and all the models and all the code that you need to run this test suite is available on GitHub in this URL. So you may ask, how does MBT work in terms of test architecture? Just checking on time. We are in 18 minutes. So we have essentially a test engineer designs test models and runs them using GraphWalker, which runs, which calls the user interface on the client side, JavaScript and HTML, and that calls Selenium. That calls Selenium, and then calls the front end, the client side of the SUT, and that calls the back end. And then you see this kind of it may look quite complex, but it's not that complex really. Everything just talks with the mod, with the component besides it, and then as you saw the result, everything runs in harmony. And if there are faults, we can catch it, because the whole point of testing, right, is to catch faults or to see that there are no faults. Okay, now back to Mr. Alper. After several minutes, he will kindly mention. I just want to mention. So once we develop these models that you saw here, we need to write some Selenium Java code to actually implement the behavior of those nodes and edges. So I will give to Alper. Thanks.
Thank you. So what have we done so far? Actually, we defined the model that we intend to test, which is over here. And we created a model from requirements of the login module, right? So we're defining First of all, we're defining the module that we intend to test, and then we are creating a model from the requirements of that module. And as a next step is writing the step implementation behind the model for both nodes and edges, which is the fun part. So I will mention here, we are writing step implementation by asking simply this question to ourselves: what the system should do by passing from the current node to target node? What the system should do? Actually, by answering this question, we are writing. So this question actually defines the action behind the edge as a step implementation. And now we are writing. Actually, we are writing Selenium Java code for the step implementation. Actually, defines the system, what the system should do to pass to the next node, right? So yes, for this slide.
Great. Thanks for yes. Exactly as Alper said, for example, in this, I just mentioned an example of the code, right? So, for example, you have to find elements that finds by username, right? In the page, you have the username and password, and then just clears them, sends the key, enters the data, and then etc. Yes, Mr. Alper.
So, here, so we are testing our test automation tool, right? Yes, you heard well. Basically, we are testing the test tool with model-based testing approach. About the metrics of the project, we created 18 models for full covering the test tool, actually. And in 18 models, we have 170 nodes, right? And we connect these nodes with 288. And the size of the Selenium code for all nodes and edge behavior is 4699. And each test run takes almost 6 hours. It's in some cases it may up to like 11 hours with 100 edge coverage. We define, this is the good part of model-based testing, that you can define your desired coverage. You may ask for edge coverage, full edge coverage, or you may ask even 50% edge coverage or transition coverage. You define your coverage. So in this case, we're mostly defining 100% edge coverage, and it takes 6 hours. Okay, so for me.
Exactly. I just want to mention that, that the full execution, just to kindly add to Alper's input, it goes through about essentially 28,000 test steps. Test steps are nodes and edges. The models that you saw, from node to an edge is one step. So it goes through 28,000 of that. So, yeah. Go ahead, please, Alper. Oh, sorry. I have to. Okay. The next step is really, once we did the model-based testing, it's a natural question to ask, right? How beneficial it has been, right? What kind of benefits it generated for us? So Alper will mention those to us.
Thank you. So, I can tell a lot about benefits of model-based testing and how it changed our approach to looking at testing, right? So, but if I need to mention some of them, tangible benefits of model-based testing, first of all, improve test case design practices. In the old approach, that we were manually designing our test cases, but it was good, but we were detecting many duplications in our test codes, right? In our also test cases, test scenarios, we were detecting many duplications, and from the requirements through the test cases, there's a steps, some forgotten steps. Actually, this is the strong side of model-based testing. It's not let you to forget test steps. So this is the really great way. Actually, it's improved our test case designing practices. Detecting real fault during regression testing. Before model-based testing, we were detecting many faults, but model-based testing has really improved our fault detection that we couldn't detect before, because one of the strong sides of model-based testing is it executes the system randomly. So even when we designing our test cases manually, still we were putting our cases in a scope, right? That's we defined, do this, and do that. But in model-based testing, it executes the system randomly. So it creates a different approach actually, and it increases the false detections by the same way. And measuring code coverage. Now we are measuring our code coverage, which in both client side and server side. Also, we are answering this question, which is really important about testing side. That what's the requirement coverage, our requirement test coverage of our system? Now we're able to answer this question really well. Intangible benefits of model-based testing. According to feedbacks, actually, we have received from our teams, model-based testing has made work of test engineers more interesting and more organized. But how? Now, before model-based testing, as I said, we were designing manually test cases, but now actually we are creating new models. We are looking in a new perspective. We are designing how the system should act actually. And also from this approach, we are looking the system is more, we see the system in a more bigger picture, right? So it helps us to understand more the system and also design our cases very well. So it helps a lot actually.
Great, thanks a lot. Just to add about this little Google search idea that we have added here. So in testing overall, so in test automation and testing, tangible benefits are also important, and also intangible benefits. I just wanted to mention that because many test engineers and managers perhaps just want to measure things, of course, concretely, which is good. But sometimes when it makes something more interesting and more organized, of course, it's hard to measure this by numbers. But those are, again, very important in the world of testing. I just want to mention that. And also, as you can see in the online conversations in this Google search, many people are talking about intangible benefits as well. Here, as you can see, they call them hidden benefits of automated testing, for example. Okay, now the turn comes to me. Thanks, Alper. Well, we are almost ready to summarize and conclude our presentation. I would like to mention about so this is an ongoing work. We have started since the beginning of 2019 working on this project. Our current and ongoing work we are working on several directions. For example, one of the first one is test visualization. So we are so as you saw, well, currently the test visualization is very good. We can see how the model is running, but we are going to even increase it, improve it in certain ways. For example, showing the number of times that each agent or each node is covering at runtime. We are trying to improve the test tool because it's an open source tool to incorporate fault tolerance when an assertion fails. By the way, we are in contact with the development team of GraphWalker, so we're going to collaborate with them as well. We want to actually, for those of us who are familiar with mutation testing, which is fault injection, we want to see, because, well, some of our systems around our tests really have high quality and they don't have too many faults, for example, Testinium. But we still want to inject faults as it is done in many projects and in many companies to see if we really want to test our tests. So testing our tests. And also coverage is a big thing for us in this company. We currently have made very good progress. We have developed a front end in JavaScript, some tools that we are able to measure code coverage of client side and also server side. JavaScript in the client side, for example. So these are just some screenshots of this essential Java code coverage tools. By the way, in our online videos on YouTube, the links that we provided, there's also a video about this as well. So you can watch that as well. This shows the coverage that goes between 0 and 100% of coverage of the current page. So this is kind of the login page that it starts. And again, I just want to refer you to the other video. So now we can compare the grasses before MBT and after model-based testing. As you can see in this grass, the grass for us was, of course, the situation and the state of test automation in the company. And it actually got better because actually Alper mentioned several of those points. I just want to summarize that we have seen many benefits. in coverage, in making the work more interesting, test case design, and everything. It has helped us to by providing clarity and roadmap, right? So test engineers can know what to do next, right? So they will just develop the models. When all the models finish, testing finishes. Then you can just run them, resulting in high quality test scripts because model-based testing actually makes everything localized. So if you are working on login, you just put the code of Selenium of login in that page. You don't put it in everywhere else. So it makes things modular. And also in terms of maturity model, there are many models as you have seen, 5 levels. And as we go higher, we increase our capability and maturity. So it has clearly helped us, such as in TMMI and then TPI and other models. Just want to summarize also that this project was a part of a large international EU project called Testomat, which is next level of test automation. You can see the URL here. And there are many different topics are essentially done in this project. And I think the time is 31 minutes, so we need to summarize. We can find all the information in this page and in this URL. So that was all for our presentation. This video is an online video, but we will be glad to receive your questions via this email address that you can see. Thanks a lot for watching. Mr. Alper, do you have any final words?
Thank you. Thank you very much. It was a great, amazing experience and work for us.
Yes, we look forward to receiving your comments and questions below this video or through email. Bye-bye.